Hello everyone. Good morning, good afternoon, depending where you are joining from. Thank you so much. I know you're a few minutes late due to technical issues, but I'll cover up this time. So my talk is about Cardinality Estimator, as I'm sure you have seen in the agenda, and I am not going to talk about myself, but I want you to take a note of my contact on the left side in case after this presentation, if you have any question, comments that you want to get in touch with me, you can do contact through my webpage, through LinkedIn, Twitter, or send me a direct email. I do monitor all four of these, and I will surely respond to you within a day or two. We'll be talking about a couple of definitions, then we'll talk about what is cardinality, and the main point of this talk is why cardinality matters, right? Unless you appreciate the reason of this talk, there is no for you there is really no benefit of listening to it, right? So we'll talk about why as a database professional or as a data professional we should care about cardinality of our data, and then we will look at couple of like DBCC show statistics and couple of other things, so we know how the SQL Server engine estimate those numbers when we are executing our queries. So let's dive into this. And I'm sure there is a question and answer panel. So if you have any, please put it there. And I will definitely answer those. You can put your questions anytime. I do not mind. So I'll, in the right time, I'll take a break and answer those. So let's talk about some definitions. Predicate. Why do we care about predicate? So whenever we submit a query to the query engine, uh, there is the cardinality estimator process are interested in the predicate that we define. And a predicate is an expression that it can evaluate to true, false, or unknown. And predicate can appear in a where clause or in a join clause in a database query. And what it does is filter out the qualified rows, right? So if we have a data set that has bunch of rows, the predicates will filter out and give us exactly what we are looking for. And there are primarily two types of predicate. One is a join predicate and one is a filter predicate. So instead of me talking about this, I can show you an example. So as you can see in this query that it's a simple select between two tables, and there is a join predicate on the customer ID on the order and customer table. And we also have a filter predicate on the where clause on the date. The date has to be equals to whatever that is. And we have another filter after doing the group by where we are saying the count has to be greater than 2. So this is important, and once we go forward and look at a couple of other things, then you will appreciate why we should be aware of what's a predicate. Now after talking about predicate, we should also talk about predicate selectivity. And what does that mean? In a simple English, it means that if I have an input set, a data set, or say a total number of rows or records in a table, with the predicate, the fraction of rows or the percentage or the number of rows that qualify that predicate, that's the predicate selectivity. Again, let's look at an example instead of going through the theory. So here, if we see that we are looking at sales.orders table, but we are passing a predicate of customer ID 577. In that sales.orders table, we have total 73,595 records, but because we put a predicate that our customer ID has to be 577, only 75 records out of those 73 plus 1000 records qualify that predicate. So our selectivity of our predicate in this case is, as you can see, it's decimal 0010. This also plays a vital role during the estimation of the cardinality. There's another term is a density, and density is a very generic word, right? If you look up in Wikipedia or in some other scientific dictionaries, or journals, you will see all kind of definition about density, right? It depends on the context that you are using this word density. If your context is a chemical or liquid, it's totally different. In in terms of the data set, or for our data professionals, we can say in a simple English is how often a duplicate value occur in a column. So you're talking about the density of a column. The higher density means we have less unique values. The lower density means we have more unique values. And as you can see from the formulas, if we take again an example, if we are looking at again the sales.orders table which you've been looking, if we do a count distinct, we'll see that we have 663 unique records, and if we divide that 1 upon 663, that's what we get, and that's our density for that column customer ID. So we looked at a couple of definitions. Now, what is cardinality estimation, right? So going back to the title of this talk, know your cardinality estimator, right? Know your cardinality engine. So what's this cardinality estimation that we've been talking about? Again, if you look at different literature, you will see all kind of definition. Um, but for our sake, for our data professionals, when you're talking about in terms of a database, and we are talking about cardinality estimation, in a simple English, I can say, if we look at an execution plan, for each operator in a query plan, we'll see two different kind of estimation. One is the estimated cardinality and one is the actual cardinality. And what do I mean by that? That means the number of rows that the optimizer guessed that this operator would return. Now, the optimizer can guess a number of rows that will be returned by that operator, but when the query is getting executed in the actual time, that number might not match. So your estimated number and the actual number can vary. Yes, the ideal situation will be that our estimated number and our actual numbers are same. But does that happen all the time? No, it does not. And that's kind of the gist of this talk, that how those numbers get estimated by the cardinality engine. So when we are troubleshooting a query, or we are looking at execution plan, we see that there's a discrepancy between the estimated number of rows and the actual number of rows, that we have some idea how those estimated numbers got generated. Now, if we see a discrepancy, can we fix it? Sometimes we can, sometimes we cannot. As you will see during the demo, that's the nature of this business, that sometimes we just cannot, because it's hard coded in the engine, that the engine will estimate a certain number of rows, and it's a hard coded formula that you and me we cannot do. But yes, sometimes we can rewrite the query, we can use different data structure, we can do it in a different way. But how we're going to solve that, that's really not the scope of this talk because of the time. The scope of this talk is to how we can identify when there is a discrepancy, and we know how those numbers got generated, so we have some idea. So again, looking at an example, and for all of you folks, this is a screenshot from an actual execution plan. Now, if you are new to database or data profession, you really do not know what I'm talking about execution plan. um, you definitely want to look up. If you are troubleshooting queries and if you are not looking at execution plan, if you really do not know how to read execution plan, it will be a tough job for you. It will be a battle. So, and actually, there's a gentleman who is actually on site right now. He traveled from US. His name is Grant Fritchie. He is a long time MVP, works for Redgate. He has a book on execution plan. It's 800 plus page, and Redgate was generous enough uh, to sponsor that book, that you can download a PDF version, and it's a legal download. So that's one of the nice book that I have seen around. It goes from very basic to deep dive into execution plan. So look at that. So looking at this picture that you see on my screen, there are actual number of rows are 12, and the estimated number of rows is 7.6. So just round it up to 8. Now you might say, what's the big deal between 8 and 12? Probably not a big deal. 8 and 12. But imagine these numbers are in millions, so like 8 million versus 12 million. There will be a problem, and we'll talk about that. That what's the implication of this different number between the estimated number of rows and actual number of rows. So what happens when you submit a query to a query engine? It goes through a bunch of phases. So during the parsing phase, what it does, it creates a tree for us, right? So a parsing phase, it creates a logical tree, and during the transformation phase, the query optimizer, what it will do, it will create a bunch of logical tree. They are equivalent. They're equivalent variations of the tree. What does that mean? Means if you follow all these logical trees, you are guaranteed to get the same result, but there are different ways you can get there, right? So it's like when we turn on our GPS to go somewhere, you have a bunch of options, right? You can avoid toll-free road. You can avoid the roads with toll. You can say I want to avoid highways and all that, right? But at the end, we all go to the same place. So the query optimizer create a bunch of different trees, but all the trees lead to the same place. Once those trees are generated, then the cardinality estimator, what it does, it puts an estimated cost on each of the step into that query plan or into that tree. And then it adds up all those costs, and then it compares the cost. So whoever is the cheapest is the winner. So what does that mean? It means for my computer with less compute, and when I say compute, it's really not just the CPU. So the CPU, IO, together, um, whoever has to do the least amount of work will win. And then that particular plan goes to the plan cache. So why does it go to the plan cache? That's another big topic. So next time you submit a similar query, it creates a hash and it compares the hash. If it sees the hash matches, it doesn't have to go through the first 4 phase again. It will straight go to the plan cache and say, hey, I already have a plan for this query that I saved before. So it's going to grab that plan and it's going to execute that plan. So it's in a nutshell. This one slide can be a 1 hour talk talking about different phases of query execution. So what will happen if that cardinality estimation phase is wrong? Like what I was showing you before, 8 versus 12, 8 million versus 12 million. And sometimes you might see more, more um, like drastic difference, right? 1 versus millions, right? Then all your costs are wrong. That means you are getting a suboptimal plan. In the plan cache, you are getting a suboptimal plan. And subsequently, all the queries that coming in with the same hash is using a suboptimal plan. And what do I mean by suboptimal plan? Means you are using excessive resource. And let's go to the next slide. So what happened when you get a suboptimal plan, right? I'm just talking about a couple of examples. So a plan can execute in parallel if you set your max drop and basically when I say max drop, it's telling the engine to that for a particular operator, if the cost is high, you can use multiple CPUs or you can use multiple schedulers. Or if it sees that the cost is low, you can use a CL plan, means I'm just going to use one CPU. Now, based if your cost is wrong, then instead of a parallel plan, you're probably using a CL plan or vice versa. So what does that mean? What will happen? Means it's going to either run longer and you reduce your throughput and you are throttling your concurrency, right? Because now you are giving more CPU than you don't need, or you are using less CPU where you could take benefit of a parallel or multiple CPUs at the same time if you're using one of those big machines and you have many CPUs to work with. And then some of the operator during the execution of the query also need memory. To give you an example, like you need for the sort operation, for hash join, when you have to create a hash bucket, you need memory. Now, how does SQL Server estimate that how much memory you need to execute that operator? Again, based on those estimates. Now, if your estimates are wrong, either you're going to give more memory or you're going to give less, and both are bad. If you give more, then your subsequent queries will be waiting for memory again. If you give less, then you do not have enough memory to sort your data set in the memory that was allocated. Now you're going to spill to the disk. So now you're talking about microsecond versus millisecond. So you have to write it to the disk, sort it there, and you have to read it back. And there is access method, like do we do a seek, do we do a scan, or do we do a seek plus a scan? Again, depending on the number of rows that you think this particular operator qualify, that's going to get affected. Your algorithms for your join algorithm, aggregate algorithm, sort algorithm, everything is driven by the estimates. So if your estimates are wrong, um, you know all of these things that you see in this slide is going to get wrong. And again, what's the ultimate impact? You're getting a suboptimal plan, you're probably running longer, you are working more or working less than you should, and ultimately you are affecting your concurrency, means how much work you can get done at the same time. So your throughput is going to get affected. Now, why does that happen? uh, we can talk about that. That's again, this slide itself can be an hour slide, right? We can have missing stats, stale statistics. Why does statistics get stale? Because we continuously do inside update delete in our OLTP systems, but we cannot be updating the statistics with each individual change of our data, right? That's just not practical. um, Inadequate statistic sample rate, right? There is a sample rate, the statistics is based on that. If you have a huge table, that sample, the default sample might not be enough. If you look at histogram, which you'll be looking at, there are only 200 steps. It doesn't matter if your table has 20,000 records, 20 million records, 20 billion records. In your histogram, you only get 200 steps. You do not get more than that. As you will see during the demo, even if you do on a pretty smaller table 100% sample statistics, you will still get wrong estimates. And I'll show you that parameter sniffing and out of model query constructs means, what do I mean by that? Multi-statement table valued function, table variable, X query, all those are not really a good candidate for a good estimation. So those can cause some wrong estimates. I'm going to ask the organizers, is there a question and answer panel I have to turn on? How do I see people's question? If there is any, people are typing.
Was one question about the link for the book you have mentioned from the Grant Frici, from the Redgate, but I think I have already found that online and put the link on the QA.
Okay.
And I think there's nothing more questions. So
okay, so you can stop me if you see anything relevant, because I'm not seeing that question. Sorry.
Okay.
Yeah, thank you so much. Yeah, I should probably. It might be in my reference slide. I don't remember, but if not, I'll definitely add it next time. That's a very valid point. A good point. Thanks so much. So before I go to the demo, I really want to spend some time on DBCC show statistics. And why I want to do that, because this is one of the primary source that the cardinality estimator get the estimated numbers. And if you do not know how to read the output of this, I'll definitely urge you to spend some time. I'll go over it. If you are not sure, please stop me, because this is important. So a DBCC shows statistics, and I'll show you more during the demo. It has three different sections. I'm not going to read this slide. I just, for your reference purpose, you can read it on your own. So we'll look at all these three sections separately. So the first one is a header, and there's still a column that's named density, as I said, deprecated. So please, if you are looking at the density, do not use this column. There's another place which I'll show you in the next slide where you should read the density from. And these are pretty much self-explanatory. Your name, last update time, steps. Now, if you see here, you will see that my number of rows is 50,299. But if you look at the bottom row on the right, the unfiltered rows is 73,595. So what is this telling you about this index? This is telling you that this is a filtered index. So this table has 73,595 records, but this particular stats is built on 50,299. Why? If you look at my filter expression, it says contact person ID is greater than 2000. So you can have index not in all the rows of your table. You can filter it, and then you will have statistics just on those filtered rows. This is a density vector, so here you should get the density from, not the other column that you saw. And if you have a multi-column index, you will see a density for the combination of all the columns that you have, and you also have average length based on the column type and how much space that data type takes based on that. Now this is the most important part, is the histogram. And what I did here, and this is what I was talking about, that you can get maximum 200 rows, doesn't matter, or 200 steps, I should say. I shouldn't call these rows. Doesn't matter uh, how big your table is. Doesn't matter if it's 20 million, 20 billion, you only get 200. That's the max. And there's a whole white paper. If you're interested, if you want to get to sleep earlier, start reading that. It talks about how the algorithm works. How does it choose those data points to create the 200 steps out of all the records you have in a table. Now I highlighted these two records in red, and I'm going to blow that up into a little bit bigger. So try to stay with me. If you get lost, please put in the chat. I would repeat, because this step is I think the most crucial out of all the slides that I have in this talk. So here, if you see that the range high key, so like that's the key of our index. So right, this can be a customer ID, whatever ID, right? Your business ID, a patient ID, or whatever. So we have 2083 and 2091. So now if you have a query, and if your predicate is said that I'm looking for the key equals 2083 or 2091, it's very simple for the query engine. What it's going to do is going to go to the third column. Let me see if I can highlight this a little bit. No. Okay, it gets crazy, but I'll try. So if it's a direct hit, it comes to this equal rows, right? So it's pretty easy. It will say I have 119 rows, right? So if you say 283, it's 119 rows. If you say 2091, it's 106 rows. What happens if you pass something in between? Say like 2084, 85, 86, 87, any of those. The cardinality estimator, it only has 3 pieces of information for anything between 2083 and 2091. It knows that for 2084 to 2090, for all those IDs in total, I only have 332 records. It doesn't know how much for 2084, how much for 2085, how much for 2086. It doesn't know individual ones. It knows that in total, for 2084 and 2090, I have 332 rows. So you always go to the bottom one, right? If it's your numbers are in between. It also knows that out of these 7 numbers, so from 84 to 90s, there are 7 numbers, right? 84, 85, 86, 87, 88, 89, 90. 7 numbers. Out of those 7 numbers, only 3 of the IDs have records. Other 4 IDs have 0 record. Nothing. But does it know that which ones has 0 record and which ones has those 332 records? No, it does not. And even out of the 332 records, those 3 IDs, 2 of those can have 1 each and 1 can have 330. It has no clue. So what it does, it divides that 332 by 3, and if you look at the last row, last column, that's the average range rows is 110.66. So if you pass any value between 2084 and 2090, the cardinality estimator is going to estimate 110.66 records. And if you pass 2083, it's going to say 119. If you say 2091, it's going to estimate 106 records. So right off the gate, you can see that even though I just updated my statistics with 100% sample, if I pass anything between 2084 and 2090, I'm getting a number that are way off from the actual numbers. And I cannot do anything. I have no choice. That's how the engine is written. I'm going to take a pause. If any question, please let me know before I move. If you didn't understand this, I'm happy to go back and explain you again. Okay, if not, I'll move. Now, oftentimes I get a question, what happens if I allow null in my column, right? We do that for some reason, right? Because sometimes when you're building a app, there will be situations that we do not know the information. So null doesn't mean that it's zero or it's void or whatever. Null means we just do not know at this time. I do not know what is the value of this column at this time. I might know it in future. So for null, as you can see in this table, um, you know, I put that out of those 73,595, you have 3,085 records for null. And then, you know, so null you will see at the top, and then you'll see the other records under the null. Um, and I put some examples. If your key column, if your predicates you write like this, what are the possible values that you can get, right? So if you say your column is null, it will estimate correctly that you have 3085, and then it goes to the next value. So I'm going to go to the demo. I do not have any other slides, so we'll talk about a couple of these things. I'm not going to read all this. So all this we'll cover in the demo. And I'm going to be using a SQL Server 2019 CU16 with SSMS version in case if you want to download my um, code and want to run this so you know that what environment I tested this. It should work in other versions, but I haven't tested other versions. These are some of the references that I have that you can download or you can look at. I use some of these to when I was preparing this talk. So I'm just going to bring my SSMS. I'm sure you can see that. So what I did is I'm not going to run this again. I did run this before I started the session, and I put enough comments here that you should be able to download Wildward Importers, which is given by Microsoft to set this up, and then you should be able to run the subsequent queries that I have. And I did do updated statistics here, as you can see on the sales.order. And yeah, I'm also setting up the compatibility level to 140, which is a default for 2017, because in SQL Server 2019, because of the intelligent query processing feature, there are a bunch of those in a family. Some of the stuff change, and whenever there is a feature that I'm talking about that change in 2019, I'll mention this and I'll change the compatibility level to 150 and vice versa to show you both. This is another thing that if you do not know what's the compatibility level, you definitely want to study on it, because as you are looking at cloud, Azure SQL database, there is really no concept of SQL Server 2017, 19, or 16. There is only one concept, that's a compatibility level once you move to Azure SQL database in PaaS, and that's how you can control the behavior of your database. So you definitely want to look at that. The first query that I have, oops, I don't know. Okay. Strange. Why can't I? Okay. So this one is really, this is not technical. What I did, let me run this to show you. So what I did here, I wrote a couple of TSQL and I generated some of these numbers that, okay, so let me run this actually. That's the output of DBCC show statistics that I was showing you during the, in the slide. Now, some people look at this and, some people, get overwhelmed with all these numbers, right? They think, there are like, deep formulas behind the scene. How do this get generated? I have no clue. So just to break that fear, what I did, I generated some of these numbers and I did put description what each of these number means. And the reason I did this, I just wanted to prove that these are not any numbers that we cannot crack how this was generated, right? As you can see that, I did bunch of union all, but most of these I wrote just simple TSQL that you can do some count, and do some conversion and all that, and you can actually generate all these numbers. So looking at these numbers, don't get overwhelmed if you're new to this. With reading and the references that I put, you should be able to mimic those numbers and write T-SQL to generate those. Do we need to do this? Probably no, but just if you really want to get into understanding, what's happening behind the scene, how the query plan, when you look at a plan, where that estimated number of rows came from, this can be helpful. So let's close this. Okay, so here's our real demo start. So I'll be using Wild World, Wild World Importers database, and I'll be turning on actual execution plan. You can turn it on with Control+M. There's also TSQL you can use to turn it on. There is also a button in SSMS. There are also a bunch of improvement happening in Azure Data Studio if you are using that to look at the execution plan. And there are two different ones, right? One is a estimated, one is a actual. What is the difference? Of course, on the estimated one, you do not run the query. You just look at the query plan, and you have an idea that if I execute this query, how it is going to get executed. But on the actual one, you really get runtime stats, right? Because it ran, so it collects the runtime statistics, so you can see both what was the estimate and what is the actual. So let's do this, and I'm going to turn this on from here. But next time I might just do Control M, which you cannot see. And this is our actual execution plan. Now, if we look at here, this is our estimate, and this is our actual. This is perfect, right? Because we got 89 on both. There's no discrepancy. Now, why does this 89 came from? So look at our query one more time. We have contact person ID equals 1025. Now let's go and look at the histogram. This is 1025. If you remember, I told you before, we come here, if it's a direct hit, we go to the third column and 89. So in this case, it was a direct hit to the histogram. So the estimated number of rows and actual number of rows are same. Now, I told you that during the data modification with insert, update, deletes, every time we do one, this is not practical to update the statistics with each change. So let's look at something. We're going to insert some records, and don't worry about this, how I'm doing it. I'm using a Go 5. It's a trick to run this query 5 times. And so what we did here, we inserted 2,759 records. Now, did our statistics get updated? As you see, my local time is 5:12 a.m. I updated this, right? I'm in East Coast. Your time is right now probably 12:20. If we run this again, as you can see, it didn't change. So what does that prove? That proves that with these inserts, my statistics didn't get updated. Now, if I clear my cache and I put a warning, do not do this in your production server. If we run the same query with the 1025, and Because we inserted more records with that same ID, our actual number is 2848 because we had 89 and then we inserted a bunch of records. But look at the estimated number, 92.3365. So where did this come from? So what SQL Server does, whenever you are inserting record, even though the stats are not getting updated, it does check the total number of rows, and if it sees that the total number of records over there is 73,595, but in the table the actual number is actually more because we inserted 2,759, it tried to do some scaling. And what do I mean by that? So there's a formula. See that 92.33, so that's the exact number. So it takes the new total number of records, multiply that by the direct hit of 89, divided by number of total records that we had before. You know, as in this case, we saw it's, from 89 it went to 93, but actually our actual number of records were way high. So again, you can see that even if you do everything right, what Microsoft recommended, you will still see there's, discrepancy. And like I said again and again, oftentimes you really cannot do anything. So I'm going to run this, put things back together again. So I can proceed with it. I'm going to get rid of those records that I added. This time we're going to use a different ID. So you're using 1025. We're going to use a 1057. Okay. And if we look at the execution plan this time, we see that our actual number of records are 109, but the estimated number is 118.667. So where does that come from? And look at this number again, 1057. So let's go down. So 1057 is in between these two. And as I said, you always go to the bottom one. What is this 356 telling us? That any IDs between these two means from 1056 to 1062. In total, I have 356 records. Out of those IDs, only 3 has records. 356 divided by 3 is 118.6667. And that is where the cardinality estimator got this number, 118.6667. If you use distinct, and if you have a unique column, actually no, as soon as you use distinct, and if you have a index on that, SQL Server is pretty smart. It will figure out. So like, here you have the 663, and the 663 actually came from here. It's using the density vector that I showed you before. So as you can see, 662.9998 is going to round it to 663. And where is this number coming from? Right here. That's the density for this column. So it will use this because it's looking at pretty much how many unique values I have. So I'm going to close this. Again, if you have any question, just type it in. If I'm going too fast, if you're not sure, I'd rather answer questions than finishing it, because you can download this from my GitHub and you can run this by yourself. I put enough comments in all of this. So we looked at a single predicate, but oftentimes, as all of us know, when we are writing our queries, we are not just writing a single predicate, right? Oftentimes we'll have multiple predicates. and things really get complicated. And in the interest of time, what I did here, I put a big notes, and I also put two links. These are question and answer from dbastackexchange.com. Um, I'm not sure if all of you know who Paul White is. He's from New Zealand. I kind of consider him is one of the master of this topic in our community, and I learned a lot from him. So I had a couple of email discussion when I was preparing for this talk, to understand this a little bit, to make sure that my understanding is correct. And so I put a lot of notes here. As you will see that even just when you say that, the contact person ID, we're looking at like either 1025 or a single one. As soon as we say between 1024 and 1027, things can get complicated. So I kind of explained this, how this thing work, from step by step. So you really get into three different steps when you do that, and then how each of these steps get estimated, and then how all three numbers get aggregated, and it gives us an estimated number. So read through that. If you have any question, please again get in touch with me, and I'll try to explain further. So if we do this, a single like between this, turn on our actual execution plan. As you can see here, we get 342.625, and our actual number is 211. And again, I explained exactly here how you get to this 342.625. And then if you run this one, I'm not going to run this, you'll see the number is 1236.17. Again, you have to go through all the steps, if you want to find, the numbers between 10 and 20. But what happened is what changed in 2014. So when SQL Server 2014 came out, there was a big change for Cardinality engine, because that was the first time. I don't remember exactly. I believe since SQL Server 7. I only used 2015. I haven't used any version older than that. 2005. Sorry, I start. So in 2014, the Cardinality estimator was rewritten, and that's why oftentimes you'll see uh, that there's a lot of talk that if you're upgrading from anything older than 2014, you want to be careful. Hopefully, you folks do not have 2008 anymore, and 2012 is getting out of support on July 12th. So we'll all be in a newer version. But if you still have older version and you are upgrading, you want to be careful, because there was a major change in the Cardinality engine. So and I'll show you an example here. So now if you combine those two predicates that I have here, this one and this one, and if you do a AND, you get a number of 44.4052. Now, how did this number get generated? This number was different if you're looking at a pre-2014, and if you're looking at 2014 plus, this number is different. So if you run this query in two different environment, or by changing your compatibility level, you will get two different answers. And why is that? So when you have multiple predicate, pre-2014, what SQL Server didn't do, it did not give any weight to the selectivity of the predicate, right? So it kind of treated every predicate in the same way. Doesn't matter if you are more selective or you are less selective. Everybody was treated same. And what it did, um, as you can see here, it multiplied everyone. But in 2014, what it did a square root. So as your selectivity is less and less, you get less important. And to make you less important, what it did, it keep doing a square root of it. So you have less impact on the overall number. So if we run this, as you can see that in 2014, the estimates is 44. What we saw, if you were to run the same query in pre-2014, the estimate was only 4.3. So yeah, both are way off from the actual numbers, but at least as you can see in 2014 plus, it's more closer to the actual number of rows. Now, does this guarantee that if I upgrade to 2014, I'm going to see improvement across the board? No. There can be situation, and I'm sure if you play with it, you should be able to generate numbers that you will see it goes in the reverse direction. And if somebody wants to play with the pre 2014, I put the query here, right? You can do it in a bunch of different ways. You can say force legacy cardinality estimation. You can also do it. There's a trace flag also. You can use 9481. You can go back to the old cardinality estimation. So I'm not going to run this in the interest of time. But I put this in this section if someone has older version and you want to play with it. I also have another query with the OR statement, right? I'm not going to run this for the interest of time. We saw the and this is for the OR. So the next one is the parameter sniffing, and you will see a lot of talk about parameter sniffing. There are a whole hour talk, but I just want to show you a couple of things with the cardinality estimation. So I'm creating a very simple store procedure as you see here by using this select with the contact person ID. Now, once you create this store procedure, we call it for the first time, right? With the 1025, which you saw before. And we know that the numbers are going to be 89. Now, and we know that this 89 is coming from here. Now, what will happen if I run this same store procedure with a different value? If you remember in the slide, I talked about something that after it selects the best plan with a list cost, it put the plan in the cache. Because if you're coming with the same query next time, I don't have to go through all those phases. So we ran this query with 1025. Right now I'm calling the same query, which will generate the same hash with a different value. And if we look at this, 1089, sorry, it's only 89, right? But we saw that before, if you're passing 1057, we are supposed to get 118.6667. Why you didn't get it? Let's look at something. And just keep that in mind, even just not for this talk, even at your work, when someone say, this query was running good in the morning, now it's not. See, this query is compiled with 1025 and its runtime value is 1057. So oftentimes you'll see people will come to you with if you're DBA, or 2 hours ago this was running fine, now it's taking longer time. Probably, they're calling you with a value that qualifies for a lot more records. And the way we can prove this, if I clear the plan, and this is a nice way to clear the plan for just one query. So I evicted that plan from the cache. I run this again. And now you'll see that we get 118.667. And if I come here now, right, look at the compiled value and the runtime value. They're same. I now have 4 minutes. I still have a couple of queries. So is there any question? I'd rather answer the questions than going through other demos.
There is no questions on the room and on the chat as well, so I think all is clear
Okay.
and you can continue.
Thank you. So let's talk about unknown. And when I say unknown, it's again a big topic, right? Because we do not normally we don't write raw TSQL, right? Most of the time we'll be running stored procedures, functions, and then we'll be passing values that to run that stored procedure or that function. And SQL Server sometimes do not have the knowledge of the parameter that we are passing. So here, as you can see, instead of hard coding the order ID here, I'm passing it through a variable. And in this case, because this is a unique column, we are good, right? Our estimate is 1, our actual number of rows are 1, which is good. But if we do the same for contact person ID and for 1025, we know that 1025 qualifies for 89 records. You saw that few times. But let's see what happened in this case. We know that the actual number is 89, but look at this. 111.003. So what happened? Because we are passing this and SQL Server has no idea that we passed 1025, it will revert to the density and the total number of records, and it will generate this. So doesn't matter what number I put here, any number. I'm just picking a random. There's no record. You will still see 111.0003. So be aware of that. Now the other one is a table variable, which I mentioned briefly that there are constructs that you need to be careful. And I have option recompile here. As you can see, I have 271, but if I script this out, I do not do a recompile, you'll always get 1, right? There was some improvement in 2019 called table variable default compilation, so read about that. And there are a bunch of others that are hard-coded that I put here, like if you are using these operators, right, greater than, less than, greater than or equal to, it's hard-coded 30% of the total number of records, you cannot do anything. If you are using a like operator, it's 9% of the total numbers. So there are a bunch of formulas that I put here that you and me we do not have any control. So I know I'm out of time. I'm not going to go through again and take more time from the next speaker. There is another one called ascending key. This is also very interesting, and oftentimes we run into this problem if our inserts are always at the bottom of the table, like if you have a date time or you have an incremental ID that's always increasing, but your histogram doesn't get updated with every insert. And so now if you're querying from the tail of the table, that's not in your histogram, how does that work? So this is very interesting. Oftentimes we run into this, but people just doesn't know how the cardinality estimator is picking up those numbers, then it's hard. People just struggle to solve it, right? If you are in an older version, there's some trace flags I mentioned. On the newer version, there is some padding, that's built in that the SQL Server automatically takes care if it sees there are records outside the histogram. So read those, and if you have question again, get back to me. And again, these are, my contacts. And I want to thank the, sponsors. Without them, it's hard to bring this, such a large, seminar worldwide, right? The organizers, volunteers did a phenomenal job. It's in person and hybrid. So people like us, across the pond, we can talk and you guys can listen to. So thanks to everyone. And again, thank you for joining. And I know we had some hiccups at the beginning, so last few minutes. You can download all this. I'm going to upload, and I know I kind of rushed at the bottom at the end because of time, but I'll be happy to follow up with any of you if you have any question.
Your session.
Thank you. Any questions or comments in the chat? Do you see or no?
There was one more about where to get the SQL comments, but as you already spoken, they are on your GitHub, and I have sent the link on the chat.
Oh, thank you. Thank you. Okay then. Thanks a lot.
Thanks once again.